everyone. We're going to work out this very interesting example of probability. So suppose that A and B are two events, and knowing probability of A is 0.5 and probability of A complement and B complement is 0.3. We want to know what is probability of B when A and B are mutually exclusive and when A and B are independent. So these things have their own definitions. So mutually exclusive, we know that means probability of A intersect B is 0, meaning these two events cannot occur at the same time. And if you assume independent among events, then this means the probability of A and B, you can simply multiply their probabilities. This is probability of A times probability of B. So these are the two things we're going to assume as we figure out the probability of B. So from the first part, we know that A and B cannot occur at the same time. So let's draw a picture to help you understand this better. So if they cannot occur at the same time, then you can imagine drawing two sets, A and B. Then if this is A, this is B, we can fill in probabilities. So think of it as, we know that probability of A, the chances that A will occur is 0.5. So that means we can put 0.5 here. Then A complement and not B, so I'm looking at this right here. Well, that's going to be nothing in A and nothing in B. That's outside of the circles inside the rectangle. So this is going to be 0.3. We know, so we don't know what this is. We don't know what probability of B is. So that means we can figure it out from the knowledge that we know sum of all events in a sample space has to equal to 1, the probability. So we can create the following equation to figure out probability of B. So we know that probability of B plus the probability of A plus what's outside of those circles, that's probability of A complement and B complement. Everything should add up to 1. So I know this, I know that. I can subtract them and I get probability of B. So we can write this as probability of B should equal to 1 minus probability of A minus the probability of A complement and B complement. So let's substitute these numbers. So we do 1 minus 0.5 minus 0.3. And this will give us 0.2. So that will be our results for probability of B if these events are mutually exclusive. All right, for the next part, we're going to assume independent. So we know that for part B, we're going to assume A and B are independent. So that means independent events means probability of A and B is equal to the probability of A times the probability of B. All right, so we know so here you're gonna have to draw a Venn diagram like this. So there will be something in the intersection. So you have Venn diagram like this. So the only thing we know at this point is this is 0.3. So that was given to us in the problem, probability of not A given and not B. So that means this portion right here, A union B, it's going to be 1 minus 0.3. So we know that probability of A union B has to be 1 minus 0.3 because that will give us what's belong to each circle and the intersection. So once you do that, you're going to get 0.7. All right, now using our formula for union of events, let's hold on to that. So we have probability of A union B is given as probability of A plus the probability of B minus the probability of A intersect B. And we know what this is. Since we're assuming they're independent, that's going to be the product of these probabilities. So we're going to substitute that in here. So this is going to be replaced with probability of A times the probability of B. Now we know what the left side of the equation is. So we know this is going to be replaced with this 0.7. We solved that already. And this is equal to probability of A that is given to us in the problem right here, 0.5. So we're going to go ahead and substitute that here. This is 0.5. Probability of B is what we're looking for. So this is just probability of B minus probability of A. We know that's 0.5. Let's go ahead and substitute that and times probability of B. All right. Now you can think of these as common terms, so you can combine them. So that would be, if I combine them, I'm going to get the following. So you can think of it as that's 1 minus 0.5. So this is 0.7 is equal to 0.5 plus 0.5 probability of B. So I just combine their coefficient. This is 1, this is negative 0.5. You add them up, you get 0.5. Okay, so now let's subtract 0.5 from both sides. So just a little bit of algebra. And that's going to give us 0.2 is equal to 0.5 times probability of B. And now we divide by 0.5. So you'll have 0.2 over 0.5 is equal to 0.4. That is our probability of B. All right, so you see how the probability of B can change if they're mutually exclusive versus being versus being independent. All right, I hope this helped you understand the problem. Take care.